Okay, let's talk about computer science. It's more than just coding and programming. It's about understanding how hardware and software work together to create tools that the world uses every day. So, information in tons of different kinds of forms, like text and spreadsheets and pictures and video, it all needs to be represented in a way that the hardware and software of a computer will understand it. But it also needs to change in a way that humans can understand it. And so let's focus in on a keyword. That keyword is abstraction. To make that information change from one to another, it's a pretty complex process. And so abstraction is necessary. Abstraction for what we see and hear and understand, to convert that to digital so that a computer can accept it and process it and then return it back to us. That keyword abstraction, let's go ahead and define it. First of all, let me show you that this is one of 7 big ideas of computer science. Number 2 there, abstraction. We'll tackle number 1, creativity, at another time. But right now, let's focus on abstraction. This big idea of computing is to make it abstract. You can see that there's a keyword kind of hidden in there, abstract. And what does the word abstract mean? Abstract means thinking about ideas instead of events or details. And so abstraction is to make something abstract. And in computing terms, it's focusing on what is most important for the task at hand by removing less important details. That's a pretty complex idea, so let me show you an example that might help to make it easier to understand. So let's start with the little laptop in the left-hand corner there. Number 1, so we're going to have the pink dialog start this little conversation here between all these machines. So the laptop says, I need directions on how to get to this website. And so let's go over to number 2, where the DNS server, another computer, is storing all the information on how to find websites, and that DNS server actually doesn't know. Doesn't have that information, and so it, follow the pink arrow over to number 3, it asks a fellow DNS server who does have the information, and now the conversation is in yellow, and let's follow the yellow arrow back to the first DNS server, number 2. And so, oh great, thanks for that information, I'll save it for later. And so the yellow arrow goes back to our laptop, number 1, and now it's interested in being able to find that website, and now it has the directions that it needs, and so the green conversation is thanks for those directions, and now I'm off to that website. And so you can see that it finally makes its way, the green arrow points to the actual website where the information is stored. Now, in order to use the internet, you don't have to know how the internet works. So this picture shows kind of behind the scenes what goes on. You click a button and then all this happens at the speed of light. So by getting rid of those details, that's an example of abstraction. We're taking that detail about all that information and we're removing it so that we can focus on the most important detail, and that's getting to the internet. So that's an example of abstraction. To see an artistic or visual representation of abstraction, you can get on Netflix and watch the show Daredevil. And the opening sequence of that show, it's kind of this red-themed, very cool-looking CGI where all these forms, like a statue and a water tower and a bridge, they all begin to visualize because of this red wax or paint that's being poured all over top of it. It's really cool looking. And that's an example of abstraction because the details of the bridge, you don't see cars on the bridge or people walking across it or what color it is or where it's located in the middle of this body of water. You don't see any of those details. Instead, you just see this bridge being formed. And so it's removal of those extra details to put the focus on just kind of one key important detail. And that's an example of abstraction. So in terms of computers, humans need to interact. We want to touch the computer, press the keys, move the mouse. We want to see the visuals pop up, icons and characters and images and videos. We want to see all that information pop up. But all of that information is stored in ones and zeros on the computer, and we wouldn't recognize it if we looked at it, because we're not digital. We're analog. Humans are analog, and we need to be able to see information differently than a computer. So we need abstraction that can change all the complexity of a computer's inner workings with the software and the hardware and how all that works together, and we need to simplify it so that people can interact with it. So abstraction means that the software and hardware are working together to process that information from something digital into something that you and I can see and hear and understand. Now, all of this happens in ones and zeros. We mentioned that. A computer understands the world using ones and zeros. And so let's look at another keyword called binary. Binary means having two parts. And an example of something that has two parts would be a light switch. It's either on or it's off. And binary, in terms of a computer, is talking about ones and zeros. The one represents on and the zero represents off. And that's really all there is to it. But the way that those ones and zeros are sequenced can mean different things to the computer. And so somebody has been very effective in coming up with an abstraction so that we understand what the computer is doing, because it presents its information. It does all the hard work behind the scenes and then presents that information. So whether it's a text that you receive from your friend or a picture that you get on your mobile phone, maybe a game that you're playing against somebody who's on the other side of the planet, or any number of other things that computers can do, it all happens with this basic unit called binary. So what is binary? Well, in computing, it's the language of the machine using only ones and zeros to represent information. And this is how computers transmit and process and program information and data. All of these binary bits, they represent the numerical values and the characters of text, the images, the videos, and the instructions for the computers to follow. So all computing in the past, what we have today, and even things that are going to happen in the future, things like AI, artificial intelligence, or virtual reality, or voice recognition, or self-driving cars, all of these come about because of these basic ones and zeros and how the computer processes that. So your job as a computer scientist is to understand how software and hardware work together and be able to write programs that are going to help computers to be able to do the things that humans need. And that's abstraction using binary. There you go. So your next task is to be able to contribute to the Padlet. Associated with this Google Classroom assignment is another link to a website called Padlet. And if you click on that, you're going to want to sign in just like you do with Google. And then go ahead and post some things. You can see that most of the people in the class have already begun to post. And so it's kind of a who can post the most relevant things is what this Padlet is all about. So you have a lot of time to be able to do that. And I would encourage you, after seeing this presentation, to go on the internet and look for, we'll call them artifacts, or things on the internet that you think are relevant to understanding computer science. Maybe you can find an example of abstraction, or an example of binary, or any of the ideas that we've talked about during this presentation, and put an image on there, or a video clip, or even just type a definition, and go ahead and post that onto our Padlet. And feel free to watch this again if you need more information. And otherwise, go ahead and hop on to Padlet and try and post some relevant information. Whoever posts the most things wins. So good luck to you. Hopefully you can find lots of good stuff.